Hello and welcome to my presentation about sorting algorithms. In this presentation, which is suitable for VCE computing students, Units 1 and 2 in computing and Units 3 and 4 software development. Let's have a look at our learning intention, that you can identify the selection sort and quicksort algorithms and explain how each one works in general terms. These are the only two sorting algorithms in the study design. So first of all, I think it's really useful to understand what we mean by sorting. Well, for our purposes, what we mean is having an unsorted array of numbers, so they're not in any particular order, and we're going to sort them in ascending order, so we're going to have the smallest numbers to the left and the largest numbers to the right. It's not part of the study design, but you can also sort strings, and you can sort by multiple things in spreadsheet programs, and in fact that's a fantastic skill to have, but it won't be covered in this video. So let's start off with what we already know. What process would you use in your head if you were going to sort these numbers here from smallest to largest? So I'm going to be quiet for a second and let you have a look at it and think about what you'd do. Well, I think what I would probably do, and there isn't a right or wrong answer to this, is I would probably go through and find the smallest number, which is 10, and I would break it out into a separate list down the bottom, and then I would keep doing that process over and over again, looking for the smallest number, and I'd keep adding it to the list down the bottom. So that actually involves us constructing multiple lists. The algorithms we're looking at are, I guess, a little bit more sophisticated than that. So let's start off by looking at a selection sort. What a selection sort does is it actually starts off with two components, the sorted component and the unsorted component. Now when we start off, there's nothing in the sorted component, there's just stuff in the unsorted component. So what we do is we go through and we identify a candidate for who's the lowest number. So starts off 50 is the lowest, then 20, then 30, then 55, then 10. Now 10 holds its place because it's less than 90, holds its place because it's less than 30. So we know 10 is our guy. So we swap 10 with 50. So rather than pulling it out of the list like I would do in my head, we swap them over. So now 50 is in that space in the list and 10 is there. Now 10 is now in the sorted part of the list. We're not going to bother that anymore. Then we go through and we look at 20 and say we believe that's the lowest. We check it against everything. It is the lowest. So we swap it with itself and now that's in the sorted category. We're really only looking at the unsorted category. We look at 30. It holds its place as the smallest. So we swap it with itself, it goes off into the quarantine for the sorted category. Then we think, well, 55 is the lowest, no it's 50, no it's still 50, oh it's 30, 30 gets swapped out with 55. And so on and so forth until after only, what have we got, about 7 steps, we've sorted all of the numbers. It's probably more steps than we do if we were doing it just intuitively, but I suspect that if you didn't know how to do it intuitively, if you just didn't have a strong number sense of that, then this would get you out of the woods. So, bit of a chance for you to test your knowledge. Which of these two numbers are going to get swapped? Again, I'll be quiet for a tick, have a sip of my drink while you work it out. Okay, so the one that consistently passed the test for being the smallest is 10, so I swap 10 and 60. So the new list, this is not the finished list, this is just the first step, would read 10, 50, 60, 99, 42. Okay, let's go and have a look at the selection sort in action. So I'm just going to reset this. Oh, I think that doesn't need resetting. So we're going to start sorting. So I'm going to do this manually. 64, well that's the smallest number. Oh actually, now 34 is the smallest number. Now 25 is the smallest number. And I go through and the one that's going to stick as smallest is 5. And so 5 gets swapped with 64. Now we're going to leave 5 alone. Now we're going to go and find our next smallest number. Again, the one that's going to stick is going to be 11. And so it's going to get swapped with 34. So let's let it keep doing its job. There we go. So the green ones are the ones that are locked in the sorted category. Everything else is still in play. I think 12 is going to be the one that it decides on here. There we go. So as you can see, it's not frighteningly efficient, but it makes sense. It's pretty easy to follow. I might actually stop that because that's too boring just to sit and watch that. So that is how a selection sort works. So, giving it to you in explicit parts, we divide the input list into the sorted and unsorted. The sorted portion is empty and the unsorted portion is the entire list. We find the smallest element, we swap it over with whatever was in that place, and we move the boundary between the sorted and unsorted. So, and we repeat till it's done. So looking at this, same numbers, there's our unsorted array with nothing in it, and we're moving numbers in as they get sorted, and the unsorted section is getting smaller and smaller until it's completely empty. This is what it looks like in terms of pseudocode. It's actually much less complicated than you would think it is. It's just saying we're going to cycle through the numbers. Our minimum number is 0 to start with, because that's the first item in the index. Then we're going to go and check them all. Then we're doing the swap, and then we'll go through and check from the next spot, from the next spot, from the next spot. So, with Quicksort, Quicksort uses this thing called a pivot, where you pick a number and you say, okay, let's say number 30. And then we look at every number and say, hey, is it more or less than 30? It's a little bit fiddly in practice. So let's have a quick look at it. I'm just going to refresh this to make sure. So there's our unsorted array there. So so our pivot is 97. Now this is going to be a pretty boring pivot in some ways. So where are we? Next step. So it's checking everything to see if it's less than 97. Now I actually think everything is going to be less than 97. So it gets to stay, 98. So 98's more. So it actually gets swapped over. There's 98 there. So we're keeping it at the top of the list. So you'll notice that the 98 is grey and all of these are green. So if you're higher than the pivot, you go grey. If you're lower than the pivot, you go green. So let's just watch it play out. So no great surprises here. The ones that are less than are getting dropped down the list. And again, this is a bit frighteningly dull. That was probably, I don't think you would necessarily choose that pivot. It was just choosing a pivot at random. And the choice of the pivot actually really matters in terms of how effective this is. So now you can see that these ones here are higher than the pivot. So our new pivot is 4. Now most of these guys are turning grey because they're going to be bumped up over the 4. Again, I would say not a particularly good choice of pivot. That one there, oh yeah, there we go. So what it's doing is it's splitting what's left, putting a marker in the middle and saying, hey, divide this way, divide that way. This might actually look overly complicated, but it's actually very efficient, particularly with large data sets. It's significantly more efficient. So let me just stop there. Now, you pick a pivot element from the array. That simulation I had was picking bad pivots. You'd probably want a pivot that's in the middle, although truth is it doesn't particularly matter, but there are such things as bad pivots. You partition it so that it's to the left if it's smaller, to the right if it's greater, and then once you're done doing that, you actually pick up your pivot and you stuff it in the middle. And then you go with what's left. Okay, I know I've got them in these two big buckets. Let's start with this bucket, divide it. Divide the smaller bucket, divide the smaller bucket. You can think of it almost like a binary search in terms of branching out and out. And you apply recursively, which basically means you keep doing it on the smaller and smaller sets of numbers. And each section is finished when the partition has 1 or 0 elements. So, if we were looking at this, now I wonder, so let's say that we have got a pivot of 55. We would go through and we would say, well, 50 is smaller, stays where it is, small stays where it is, stays where it is. That would get moved over to there. That would stay where it was, and that would get moved over to there. And so I'd have 55 and 90 tucked into one bucket and all the others in another bucket. Then I would pick a different pivot and I'd divide either side of that, and then I'd plonk the pivot in the middle. So the comparison between the two. With small arrays, a selection is slow, and comparatively, a quicksort is fast. With a large array, a selection is very slow, and a quicksort is very fast. They've got this this way of representing the efficiency, how it works. What else is easy to code? Yeah, this one is pretty easy to code. You could probably actually code this one off the top of your head. I would say that I would probably go and find myself a quicksort algorithm. There's one on the wiki. And so when to use it? Well, you'd use this one in small lists, or if you're just in a learning environment, and in most real-world situations, you would use a quicksort because it's much more efficient. So let's test what we know. Quicksort uses the divide and conquer approach to sort an array. Well, that's true. Selection sort performs fewer swaps than a quicksort on average. Now, I actually know this. This is true. Quicksort will always perform better than selection sort on large datasets. That's also true. Selection sort is a recursive algorithm. Well, no, it isn't. It's repeated, but it's not recursive. And selection sort is more suitable than quicksort for sorting very small arrays in a learning environment. It's the learning environment that's the key there. So, I hope that's useful to you. All you really need to do is to be able to spot one from the other. A selection sort is just going through and keeps working the list and picking out the smallest number. So, if it's just going through and saying, hey, are you the smallest number? Add you to this list on the left. Selection sort every time. If we've got a pivot that we're chucking stuff on either side of the pivot, then we're looking at a quicksort. So if you keep that in mind, and there are only two mentioned in the study design, you should be pretty right.